When you graph cube root transformations, you're graphing any equation that's fundamentally in the form y equals cube root of x, but there are, of course, transformations for that, and the transformation formula is here. But I'll write it really big at the top of the notes sheet so that it's easy to find for reference in a minute. All right. One thing that you'll need to know when you're working through these problems is how to put this symbol, cube root of something, anything, into the calculator. And to make this symbol appear in your calculator, what I recommend is hit Math button and 4. And that looks like this. So that's useful. You can use this in y equals to get yourself some points to graph. So I'll do Math button, I'll just right here, 4, this one. I could also hit 5. That X out there, oop, I have a glare. This is, I can choose what index is, so what root I want to take. This one's already set up to be a cube root, so I'll just do that one. And I'm graphing cube root of x. X is a button right here. It says x, t, theta, n. That's where I get my x from. So I can graph this in the calculator, and it looks like this. See where this little squiggle kind of changes the directions? On this side, it is looking like it goes like this, and on that side, it looks like something else is going on. Like if it continued, it would curve down this way some more. So the middle of the curve, where it kind of changes what it looks like, is the inflection point. That's HK from your transformation formula. To get a list of a table of points, you do second button graph, and you need to have your inflection point shown on the graph, and then pick some other points that are easy to reference. I'm going to go ahead and fill that in here. I'll pause. Okay, so I turned my camera off for just a moment, filled in my table from the table on the calculator, and sketched that graph in. Again, from the middle here, what's actually going on is I have an inflection point, IP, which is HK, and your graph curving this way, curving on the bottom. This is drawn in from the middle right there. You can see a little better what happens in the middle at the inflection point. As is true with your cubic graph, the domain is all negative infinity, that like graph makes a shadow where we across the my domain. To see which shadow axis, because it looks like it would be like then eventually would also be down. My range is also all real nice. The unique cube root curve is HK, and this curve, it happens 0, 0, right here in the middle. My table is my endpoint. Graph really is increasing as I go from left and x's get bigger and y's get big, and every day is another. Graph will be increasing. During or when you have and so then I would say increasing. I don't need to. This is the parent graph. Separate this out from the tree. I will do right below here. So here I have a formation equation because there's a negative here, 3 here, so I have 2 the original graph. When it comes from HK, it's easier to see what it is, so that more like transformation equation, cube root is 0 plus 3 and inflection 0, 3. Negative. Negative will be curve. So, and I'll type an F button for X. The plus 3 is out, so I have to use it from under the reticle, and I put 3 like this. Here I can, from the tool, oh, it looks like there's something, -5. I like to put as many on here as I 1, 2, inside. Oh, okay. So curve. Right. And curve and back. is strong, that is decreasing. Are a description using math vocabulary how this is different from the true of. So when I come negative 1, H is 0. So I filled in the attributes of cubic function or cube root functions, and this is just describing what A and H and K do for the graph. If A is positive, your graph is increasing. If negative, decreasing. If A, then it'll be original. Taller, and it's stretched between 0 and 1 was the rate. H is whether your graph is short. It's also the inflection point. The y component of your inflection greater than 0 shifts and